present some simple frameworks and then some kind of tactical frameworks I think every leader should be adopting as they think about machine learning. And we'll try to address separation of machine learning and AI today as well. Simple philosophy that I think that we should implement to all of our future leaders, and it's called the double diamond philosophy. Next slide. In this philosophy, people that have experience, especially at the influencer level in strategic leadership, they usually have a stubborn trigger. They believe a hypothesis that is going to happen, a problem that they need to solve. And at the lower levels, they really have to understand, how do you diverge from that leader's gut instinct or their experience, whatever data they're looking at, to see, is this really the right problem, right? Then they do research and they synthesize all that research. They use all these data signals, and then they converge on a list of problems, breaking down that problems that are super important and prioritizing that and value that. And then you get into the second diamond, which is always, what's the solution for this? The solution is based on resources that you have, timeline that you have, efficiency, and you weigh all your options there. You can go to the next slide. Within this double diamond, are we solving the right problem, and then are we building the right solution? What's the right solution? It has these phases, right? The first diamond is, it comes from some leader hypothesis of what we have to do. Everyone in the Army and everyone in the military is very good at outcomes. They actually understand very clearly decision-making of what outcomes they want to achieve. And usually they have their own layers that they're going to for their framework. The key is that now, how do we actually split up the whole scenario into specific problems? And that's usually through research and synthesis. And then you start exploring different solution concepts. Can be done in many ways. And what's the most efficient way, and what's the right thing to do? And then you think about, what's the reinforcing cycle, the validating cycle from this. If I expanded this and I put machine learning on top of this, imagine within each diamond, there's just a bunch of little points that are giving you structured data input. Right? And so now, how do you actually try to create a framework here that gives you automated data to take a lot of the intelligence out versus relying on humans? And you can go to the next slide. So this is what we talk about as Maslow's hierarchy, the pyramid. You want to get to the top, but you have to plan now. Next slide. So in Maslow's hierarchy, it's a psychological framework that if you want to get to the top of the pyramid to really serve the most intense objectives of you personally, you have to solve the base. And the same thing in data science and machine learning. The first thing you have to understand is, what are the processes and the data that you collect? What's the inputs and the outputs, right? Within that production, you might have to actually create processes and new workflows to produce more data. And I think this is where a lot of companies get it wrong. They assume that they're already producing the data that they need at the base of the pyramid to make decisions, and they're making decisions without actually having a couple data inputs that they produce, which is where they make really bad decisions. And we've seen this recently in the business world with hiring and layoffs. They haven't really looked at specifically market data inputs that they haven't collected and forecasted out for 2-3 years that showcase the debt markets, that showcase the financial crunch market. And that led to very bloated hiring plans the last 3 years, and then now the layoffs, right? And so there's a lot of things here that require leaders to actually jump in and say, hey, are we tracking this data? Are we not tracking this data? So, I always, in leadership frameworks, it's great to hear all the frameworks and strategy, but in this day and age, even if you're a top leader, you have to ask the question is, are we collecting this data? You have to get a little granular there. And if you don't give that direction, people don't panic and respond to that, which you need them to do a little bit. But then also they're gonna explore those concepts in that first diamond. Once you produce the data, it's all about collecting it. And collecting it takes many forms. Involves usually in our world in the US, privacy frameworks and other government frameworks and regulatory frameworks. The US in particular will label things as like proprietary or double secret or secret, right? and those frameworks need to layer on in collection. You just have to do it, right? So you have to apply those regulatory frameworks as you collect data in whatever anonymization you have to do, et cetera. But then the processing, and this is where, again, we fail again. Processing becomes a way that, how do you stitch data together? My human body and Mother Earth example, how do you layer the data on a common grid? When I do agriculture and I study data for agriculture, it's all about geospatial layering, meaning do I have the correct lat long, and then a temporal layering, meaning the timestamp. So if I'm collecting data from a combine or a planter or a sprayer, I have to make sure these different companies and different systems, they have the same timestamp and the same lat long. If they don't, I'm going to get inaccurate data. So then if I spray nitrogen on that acre, but I got wrong data from some other tractor, I'm going to mess up my yield for the year, right? And so you have to figure out how to stitch the data together to get the common grid, right? And this is usually the engineering problem. This is not too much to worry about. This is what the engineers can solve for you. They love this. This is the spreadsheets and the math and the scripts that they write for this, right? But now you get above it and you get to the modeling, and the modeling is where the leaders need to come back in. And the modeling is a little bit about classification. And classification usually takes three forms or factors. It's called user, session, or event. So you're usually classifying data around a user or a user scenario, meaning a person that needs to make a decision for an outcome, right? I'm very bad at military scenarios, but like if there's a scenario where you have to strategically deploy troops, whoever the person is making that decision, there's some classification they need for them, that user, to make that decision. And so you want to classify data for them to make that decision intelligently, right? Then there's a session, or a military example, probably scenario. And a session is more, could be around time, could be around geography, it could be around a detailed scenario of a sequence of events where you actually need to make a decision off those scenarios. So there's a lot of scenario planning that needs to be done there, right? And then an event is usually more about speed and precision, meaning an event's about to happen. If it's a real-time event versus an event that's going to happen in a year, we need to have that data collected and classified for that type of event, right? So it's a little bit generic, but if I paint the example of like a Google search engine, if you type in, and I didn't like this band, but if you type in Dave Matthews Band on Google search engine, you'll see this like knowledge card come up on the side. And instead of all the links you have to click through, it says Dave Matthews Band, here's their next concert, here's the ticket prices for everything. Oh, here's a little bit of their history. And those are classifications, right? The concert is actually an event classification. The session of their history and a timeline of how they formed and where they are now. And if they broke up as a band, that's a little bit of a session classification, right? And then a user classification is they have a persona of someone that wants to buy tickets. So then there's a button that says buy tickets, right? And so that's kind of a business example of how you classify data, but they're getting that data from 1,000 different sources. And then they have a hierarchy or a processing mechanism to make sure what's the truth of those sources and then to filter them out, right? Now, once you get there, you really start thinking about what's the dashboarding aspect of this. So now that we've collected and classified data, what's the dashboard everyone needs to do? And does the dashboard need to be a real-time alert? Does it need to be an email? Does it need to go to some sort of hierarchy to have a human ground truth it? And that's really the important things that happen. This is going in healthcare right now. Healthcare in a lot of cycles because of COVID really exemplified it, and then RSV, the kids flu, exemplified it this last cycle, was how do we create all this data in healthcare that leads to real-time dashboards for real-time decision-making of an ER person or a PA. And so we're seeing this in a lot of industries right now. And then you really go into the optimization of AI. Optimization is more of a machine learning framework based on probabilities. So as you get all this data, as you classify the data, what's a probability that a session or an event's going to happen? And how do I build some sort of automated machine learning framework to bet on those probabilities, right? It's a little bit of a gambling framework, I'll call it. And then AI takes it all out, right? AI replaces all of us and it's making the decisions on the probabilities itself. So that's the tactical framework in kind of this double diamond. We'll go to the next slide. So, but large scale obviously means more complicated. This was fun. I'm just kind of to break it up and go to the next slide. I just put some of these stats in here because they shock me and they scare me. And they should probably get you all excited, but also scared too, right? So Google handled 1.2 trillion searches every year. There were 71.5 billion apps downloaded in the first half of 2020. 5 billion videos on YouTube are watched every day. Every 24 hours, 500 million tweets. I think this is pre-Elon Musk. I think post-Elon Musk, it might be 100 million tweets, right? The 18.7 billion text messages are sent every day. So when we talk about data, it just doesn't have to be internal. Actually, it's actually pretty bad if it's just internal, right? There's so many other signals that you need to bring in. If I think of a simple stock trade, and I think of these private companies that are making stock trades, these hedge funds, they always talk about the proprietary systems that they have and the data they collect in order to make a trade. In actuality, 70% of that data is outside based on all these sources, right? They're getting emotional signals, they're getting semantic signals, they're getting crowdsourced signals, they're getting geographical signals, etc. So it's important you have that landscape as a leader that although you can make decisions internally off of data, you have to pull in other validating sources, especially when the signal is so high across the board, right? Go to the next one. In the heart of all of this is workflows. And so this is just like a fun little Uber app example that I pulled when I was at Uber, but workflows are so key. And leaders that understand workflows at different Zoom levels, meaning a systems workflow, how the globe works based on a little decision, down to a transactional workflow, meaning I want to take a trip. What are the 8 steps for me to take a trip, right? In this case, an Uber rider clicks the to and from destination, they click UberX and they click confirm trip, right? The workflows are key. The key is, and why I show this workflow is that context matters through the workflow. right? What was the user ID? What time did they do it? What was their lat long where they were located? Did they try to enter in their password twice? How much time did they spend on screen? All of that data allows you to make the workflow more efficient. And as you make the workflow more efficient, that pyramid model gets a lot easier. And then you go back to that double diamond model and you can get to the problem faster and then get to the solution faster, right? So in the heart of every leader, and the ones that I've seen that really mess a lot of things up on data decisions, is they just don't understand the workflow. And they don't understand the workflow at different Zoom levels, right? Keep going. So just to kind of hammer this home a little bit, data analytics are definitely a necessary function for workflows. Data with context allows you to make decisions faster than a human right now because of that scale of 100, 500 million tweets. In the business world, we always talk about this now, and we see this now with CEOs that are actually having a lot of attrition or retiring in the market, is that you have to have data as a muscle and almost a character trait now. And you have to be able to have this kind of framework to make decisions off of big data, because however big your company is, you aren't necessarily keeping up with the generational trends or all the different data signals that are out there. So we always call this the 1% leader making the decision for the right system in the right moment in time for their environment. I want to kind of emphasize that, and this is for me, that I'm giving you all a little insight where I've had success with my teams, and I've managed some big organizations, 1,800 people, 2,000 people. I've always started out with simple algebra every year. In farming, I remember I was presenting to 50,000 farmers at the Indianapolis Colts Stadium for Monsanto. And I'm transitioning them from pen and paper to digital agriculture. So they didn't really like me. The median age is like 61. Everything's in a binder still. And so, I had to empathize with all of them. And I presented to them, I was like, listen, I have the same outcome as you, it's your yield. And I understand that yield is a function of genetics, environment, and farming practices. And I know that you all have that down. Genetics, you all have covered from Monsanto. Your farming practices are generational. You know what to do here. You know your field and your environment and your weather and your local climate change. I'm not here to tell you that. You have just generational human experience there, right? And you have big companies support the rest. But what you don't know is your variability. You don't know in real time on a 160-acre field what's going on at a 2-centimeter level. And if we're talking about extracting your yield from an average 200 bushels an acre to the guy that won the gold medal for 565 bushels per acre, a 365 bushel per acre difference, that's what I could optimize for you. I can get you that 365 extra by reducing variability in your field. And me conveying that to all these farmers, empathize with them that I know the outcome that they're truly working on, but I know the outcome in a detailed problem way the first time, right? I broke it down of the fact of the 4 things that they really care about. And what I've seen good leaders do is really just start off with this equation and just say, this year we need to focus on this outcome, and it's a function of these variables. And they just understand the bigger level problem into these sub problems that make sense to rally the organization around, right? This is the farm. I just do this in for fun. So this is Jeff's farm field that we did this in. So you can see this is the first time they've seen anything digital, the farmers at that time, when we did this in like 2012. And so to them, this is like their electronic medical record for their farm field. But for them, the farmers in this stadium, they're usually not used to seeing variability. They're usually seeing this whole map as green or red, right? And then all of a sudden we started introducing that we have, based on all the sensor data that we collected, look at all these purple regions and these red regions where you're 100 bushels per acre less. And so then just resonated with them with a simple proof point that we need to manage our variability. It's a big yield thing, right? So when I do this, usually we work backwards and backcast. When we think about machine learning and advanced data frameworks, you have to create kind of a backcasting model. You start off with that simple algebra equation of the outcome you want to achieve and the variables that matter and the variability. And then you go into this backcasting state. And this is a pretty unique, I would say, in tech, it's not unique. In other industries, they're adopting this. But you're starting with the end state. What's the outcome I want to achieve? I want to achieve 365 more bushels per acre this season, right? Or over 3 seasons. That's my end state. But then in version 2, I actually need to get more sensors on the field from a hardware standpoint. And I need to get maybe a little bit more precise agronomists to consult with me to get to maybe 50 bushels per acre more. And then you go for short term this season, I just want to earn 6 bushels per acre more, but I need to do it with more service and support, right, versus content. And so this gives you kind of this little framework to work backwards from the big outcome that you're trying to achieve at a system level, right? And then what I've also seen is that you just have a lot of variety of the scenarios. You need to have all the roadmaps to build an effective machine learning model. And what I mean by that is that you not only have a product roadmap that is a little bit more about technology and features that you're launching to achieve your outcome. So for yield, I was launching features like, here's a nitrogen script analysis engine, meaning we calculated how many pounds per nitrogen you sprayed, then we put in weather, and then we said you should have sprayed this much after the fact. Like that's a product roadmap feature that we were launching, right? So then they could understand for that season what they sprayed, and then next season what they should spray. But then you also have a technology roadmap. So now instead of services and support where I used to send them an agronomist, now I might just use Chat GPT. I literally just might launch that as a new technology and feed it some agronomy data that I have over 100,000 farmers and say, I don't need the agronomist anymore because they could do better, because they could take 100,000 agronomist input instead of one agronomist, right? And then you need a geographic and strategic roadmap, right? Everything is different based on locality and environment. And I think that highlights really, really importantly, as you think about machine learning model, when we were building these autonomous tractors that really solve the labor problem for corn and soy farmers, just drop off the tractor and they would just do the tillage, or they would spray, or they would plant. It's so different in Maryland versus Illinois. It's really wet in Maryland versus it's really dry right now in Illinois, the different times of permafrost in the soil. So that tractor had to take different inputs for the same outcome. So the environment and geography matters, right? And then you think of your whole roadmap. And the whole roadmap, what I like to call is how do you figure out how to educate, support, and partner to create a bigger product than you actually have, right? The Army does this well. They have partners, they have private people, but do they do it well enough related to the outcome that you're trying to achieve? Do you have the right partners and validators in place for a specific outcome? That's the question, right? And then the trend roadmap. You want to understand your competitors, you want to benchmark against other people, and you always want to have a trend roadmap. It's a lot of work, but all of this is necessary to understand that first diamond. What's the problem I'm actually solving, right? Go ahead. And I like to say that ML is a pretty smart team member, but only as smart as you train it. It's going to be, so this is the best part about machine learning. It's your unbiased, not dramatic, won't cancel you culture product, right? Until you train it. It's like a kid, right? Until you train it and you bias it instantly. And so that's why it's super key in that first diamond. Before you go into solution of building a machine learning platform, you have to know how to train it. You have to know what outcome you're training it for. You have to be exhaustive with all the layers so you don't bias it. Because once you start right away biasing it with either bad data or good data and the wrong input, then you're going to get potentially wrong suggestions for actually implementing an action for an outcome. How much time do we have?
We got 10 minutes left.
Okay, cool, perfectly. I always use this quote when I'm working with my team. I think it's Albert Einstein that said this. I forgot now, but it's 19 days defining the problem and 1 day solving it. Especially now, there's just a lot of ways to solution things. There's a lot of technologies to ramp up pretty quick. And I still think a lot of it dives into how do you dissect a problem, a big problem, into smaller chunks to then be able to get the right solution that's really efficient to do. And leaders are always going to trigger based on whatever signals they have. But really the three signals that I've seen in healthcare and agriculture that I think are applicable everywhere, it's about speed. So you have to figure out how to toggle up your quality of information in terms of the fidelity of speed in order to make a decision. It's about accuracy and precision. And so this actually ends up being the cost factor a lot of times, is how much more do you want to spend to get more accurate and precise, and how do you actually have to get there? And then it's about resilience. What are your sources of validation when you build these models? So you have to understand your ground truth. You have to understand what does it mean to create a digital twin, your workflows. You have to keep investing in developing new detection technology. When we were building these autonomous tractors and we were getting to this reducing variability in the farm field, GPS was 68 meters of accuracy. And we had to invest in technology for 8 years that got it down to 2 centimeters of accuracy. And then we had to convince John Deere to launch a satellite system too, right? So it went from 68 meters to 2 centimeters on a farm of GPS accuracy in order to actually farm autonomously. And so you always have to think about that resiliency. And then you want to apply various different machine learning techniques and see which one comes out the best, right? And that's just more of an engineering problem itself. Next one. I won't go into all these, but we talked about this a little bit, is that a good machine learning model and a good leader here understands the different zoom levels of that outcome, right? So yield in farming, it could be a 50,000 foot weather related farmer's almanac decision and just understanding weather for the year. But then it goes all the way down to that moment that I'm going to spray my pound of nitrogen. Should I do it or should I not do it, right? And these various Zoom levels, they take that system-wide is where the top leaders really understand global complexity and all the different events, sessions, and users that they deal with, right? Season-wide, meaning over a year, usually there's someone a little bit lower level that can understand what's going on in a year time frame or whatever the season or cycle is for your decision making, right? At Uber, it was every trip. So instead of a season-wide, it's a trip-wide here, right? Then event-wide, and then the specific action, and then the reaction. And the reaction is important because you have to understand the action that you took, and we always call this after-action reviews, right? I think in the military, and to relabel the data, right? So you have to then re-understand, did I actually solve the right problem, and did I solve it the right and most efficient way? And so you have to build those feedback loops and reinforcing cycles as you tag data here. Okay, next one. So I won't go through all this, but this is for you all to get nerdy with me, right? How do you build a machine learning model? And I'll talk about this a little bit with the Uber pickups, but obviously the first thing is that linear algebra. Define the problem that you want to be solved, the outcome. At Uber, we were pickups. Getting picked up by an Uber was a $12 billion lost problem for Uber over 3 years. Isn't that crazy? $12 billion. And the reason being is that lost time in the network. So if a driver came, couldn't find a rider, cancellation. So that was just lost time for the overall pickups and efficiency. Violent actions and insurance related to it. So, and you think of Uber at scale of 900 cities, like the army in every single city, right? It's the violent actions would happen would lead to a lot of lawsuits, would lead to a lot of money, right? Incentives, so they didn't have a bad experience, so they go to Lyft, right? So $12 billion. The reason Uber wasn't profitable was pickups, right? And so pickups, we'll go into for a minute, is a big problem to solve. Pickup cancellations are not finding each other. Quality of pickups is really bad. You want to understand all the stakeholders in it. So for pickups, it's a rider and driver, and actually two other stakeholders, the city, because the city may dictate where you get picked up. They might have rules that you have to be able to pull into a digital app like a red curb, as well as Uber's marketplace, this kind of AI system that's saying pick up here because this is efficient for the next pickup. But in actuality, that pickup might be in the middle of a highway and everyone's going to die, right? So, so there's four stakeholders there. So you have to define the problem. And then you want to evaluate if machine learning is appropriate. And then there's two ways, and I think the best way is you start with structured data. What are the inputs that you have? So we have everyone's mobile phone, right? We have a driver phone and a rider phone. We have different GPS signals. We have accelerometer and gyroscopes for the phone that we can match up. But the phone isn't really put in a set place every time, so it's kind of noisy. So you need other devices. We had sensors in the driver's car there. Or can we ask for mic permissions? And with mic, you could actually do ultrasound, which you all know well, I hope. So you could turn, 5 minutes, okay. You could turn the rider driver phone and get ultrasound to match. And so all of a sudden you have this signal of, is the driver close to the rider that is better accuracy than GPS? So we had some good signals there, right? And then you want to figure out, how do we label the data? And this is where you come back in. This goes back to your linear algebra equation. What is actually a good or bad pickup? How do you define that? What's the pickup score? And this is where a leader comes in and says, I think pickup score is based on how long a rider walks, how many times they contact each other, a cancellation rate. They talk about the metrics that matter, right? Then the engineers take it over and do the engineering stuff. They decide how to clean the data. They try to grid it. They try to do classification, and they figure out, is a neural network a good approach or a Bayesian model a good approach, different approaches, which you really don't have to worry about. This is where all the academics, it's easy to implement if the academics get the theory right and it's peer reviewed, right? So it's not too worrying there. It's all about the linear algebra and the data here. And then you come back in and you tell people, how do we create a heuristic off the data? So for a pickup, how do we know it's red, yellow, green? So now that I have this linear algebra and this score, if the pickup is 50 versus 100, I'm going to call that red, automatically cancel the car and send another car. If a pickup is 80, that's actually green. We're okay with that friction. And that's where you come back in with the heuristic. Cool. To kind of summarize a little bit, and I think we'll be good, right? Yeah. Be an expert. So know your users, your scenarios, your geography, and your intelligence better than anyone else. No matter what level of leadership that you are, it requires you to develop an expertise in your scenario. Be an owner. So you have to take responsibility for the decisions from data and all the issues related to it. And the reason I say that is that I'm just seeing regularly in the business cycle, people make decisions, and then they have the excuse of, well, I had this data to make the decision, or I had this recommendation from this machine learning model to make the decision. But in actuality, you are in charge of the data that you're supposed to collect for the decision as a leader, right? Be persuasive. So you're getting things done by being convincing with data rather than commanding from experience. be an engineer. So be very curious about how the data is collected. This is where in farming, this was huge for us to ask the farmer, how do they really understand to plant this many seeds versus this many seeds in a specific acre, and just keep asking why, right? Be positive. Obviously, you're transmitting optimism to the team and organization, and it's more about confidence that you're making based off this data. I trust the data. I trust the process and the workflows we got to get to that data, and that's why we're making this decision. You're going to be a curator, and so this is where people should be able to come to you with their ideas around, hey, I think we can collect this data, or we can classify it in a different way. And those ideas you should enable as long as it meets the outcome that you're trying to achieve. And then champion your ideas all the way up the ladder. That's what we always talk about in machine learning platforms at companies. I think that's it, right?
Okay.
Yeah.
Well, we have a couple of more minutes.
Can I show one example then for 2 minutes?
Sure.
Is that fine? Okay. Sorry. This is my choose your own adventure. Yeah.
So
actually, no, we have a couple more minutes for the whole session.
for the whole session.
Oh, never mind. Let's do questions then. I thought, never mind. Sorry. Go ahead. Yeah.
So are there any questions? I'll first say something, and that is that the starting with the end state in mind, and then backwards planning is what we would say, but backcasting is very familiar to us, both at the tactical level, but it's also at the strategic, right? We start with a concept, an operating concept that goes across all domains.
That's
so the
fantastic.
layers that you talk about. And so I think that that's something very relatable, using all the different capacities to collect the information, the data points with intel, being able to, as we backcast and understand what the problem is, then being able to put those assets in the right spots to collect the right data.
That's right.
That's very much something that we can relate to. So I think being able to put it into those terms for a military audience in particular is a useful way to describe how to apply AI in a meaningful way. So that's just my commentary on what you said, and to give you props for being able to put it in, and perhaps to help for the audience as well. Any questions out there in the time we have? John.
Thanks a lot.
Yeah.
I've some questions about responsibility and accountability for AI decisions.
Yeah.
So when you think about the stakes of AI decisions, especially in military hands, it seems like in the development, it's pretty easy to point to responsibility at a certain step of development, and then maybe responsibility for the entire product. But as that product's developed and then passed on from user to user to user, and then used in all these varying contexts that may be model inappropriate or appropriate. What are the challenges that you see to accountability and responsibility for AI decisions that have the wrong, suboptimal outcomes?
Yeah, I mean, it's AI lies a lot. Is like the answer to that. AI lies a ton. And if you're not building your AI model, if you built your AI model for a specific outcome, you usually have factored in and retrained according to that outcome. But if you're using it in a different scenario that you haven't thought of, this is where AI gets very dangerous, right? And it gets dangerous on a couple levels. The first level is identity, meaning who is influencing the model for that different outcome, and how are they making decisions, and the identity of it, right? So like with this Chat GPT that recently launched, I actually don't know the identity of they're getting the input. It's a big data framework. They crawled the whole web, but I don't know the identity of it. And it's a massive issue to me that you don't know the identity of the source of it. And then also you have to build what I'll call companion apps to AI models. If it's not guardrailed and put in security frameworks that says this is really the only scenario or use case or outcome you could use it for, and there's no security and other people can just copy and adopt it, then you have to build companion apps for it that really diagnose the way that you're degrading the model, right? The way that you're degrading the framework. And so you've seen a lot of companies launch in that format now, where people are becoming a little, let's call it lazy, right? And they're just copying and pasting AI model. And so companies pop up and say, danger, danger, like this is an approach here. So if you keep going forward, like something's wrong. You forgot about this data signal, you forgot about this scenario, et cetera. And so to me, identity is a big issue. And the second thing is you have to basically fact check and validate and build companion apps to it, which are separate models in itself. Does that answer your question? Yeah. Go ahead.
In our system, we have no shortage of information inputs. That's pretty ubiquitous.
Yep.
So I got the precision and accuracy so that you can layer it.
Yep.
How else do you sort out what you're not going to look at?
What you're not going to look at. So what you're going to throw away to be efficient about it. It's there's two approaches here, right? The first approach is don't throw anything away. Let everyone play with everything, and then it might discover magical insight. And usually that's what, you just dump all your data in one database and let people query and find magic, and people, yeah, in the lake, they call it the data lake, right? Now it's like a data ocean or a data planet at this point, right? And especially with what the Army has. The second approach is you as a leader, you definitely should just focus it. And if you have, whether it's your previous experience or your gut or workflows that you're saying these 10 variables are 90% of what we need. And that 90% is what we need from an accuracy and precision standpoint. And right now that's the human in the loop concept, meaning the human's going to be in the loop of the AI model, right? And then the extra variables in there, they are configurable, meaning, hey, there's 50 other variables that we could just click on, and then we could enter the machine learning model and see how it improves. But that's where most of the world is going on, that is realizing there's a human in the loop. That executive needs to understand what are the 5 variables that really matter and what we're going to invest in, and the rest of it, and make it configurable. And configurable, it's a whole different game in the sense of you can keep data archived. Do you need some of the data in real time? Do you need it in 5 years? And so there's a whole efficiency there that you could plan with. Does that make sense? Yeah.
Any
Cool.
other questions?
Fun. All right. Some more robots.
All right.
Great.
Well, thank you very much, Birju. We appreciate your insights, and
Thank you.
we'll continue the conversation. So thanks again.